So in the earlier recording, I asked you to set up all of the information for the Spring Fundraiser, and I showed you the main code and the various class files. So I wanted to take a minute and just kind of wrap that up a little bit. And when you create an interface file, there are a couple of things here to notice. One, it says public interface, not public class. And if you go back to your menu with new file, instead of choosing Java class, you can actually choose Java interface. So you would click that and do next, give it a name, and so on. And that will put it in public interface name format for you, so you don't end up with the word class here. So that's another difference between a class file and an interface file, that you're going to actually have the word lowercase interface here instead of class. And remember that the interface is a contract. It is just a skeleton. It will never have any more code, or will never have much more code than just data type and method name. You're not going to put code in here. You're not going to put the word public, because by default all methods in an interface are public, so you do not need to put public double get amount. You do not need to put public string get name. So what this is saying is that any class file that's going to implement or use the interface agrees that it will have a get amount and a get name method. One will return the double, one will return a string, and the code for those for the implementation of the methods will actually be in the class file. The code is not going to be in the interface. It's going to be in the class file. But all the classes that agree to use measurable will have those two methods at a minimum, probably more. But that's all that the interface is. It's the agreement that everybody who participates in the interface will have certain methods with certain return types, and the coding or the implementation of those methods is left to the class file. So if we look at, for example, we're going to look at player. Now, in order to make player use the interface, you have to type implements measurable right after the class name, just like I have here. And you've got to do that for player, you've got to do that for classroom, and you've got to do that for bids. All of those three files implement the measurable interface. Notice in this assignment, however, that the group class, which I'm using to let me collect classrooms so I can compare them, collect players to compare them, collect bids to compare them, this does not have implements the interface. It is just in player, classroom, and bids. And what I'm saying once I do that is now player, classroom, and bids can take a little bit of advantage of some of the slight code reuse that we've got through the group class. And now all of these must have in them, all three classes must have a get amount and get name. So now if we look at player, of course I have my typical getters and setters. So here I've got my get name. It returns a string. So I'm good in that respect, and that's just my typical accessor method. Okay, so in each class file I'm going to have a get name method. I could name it more generically, but instead of get classroom name or something like that, each of them I'm just going to put get name in. But notice each one has a different implementation or different code, because here I'm returning the leader name. Here get name returns the actual player name. Then in bids, I'm going to have a get name method that returns the item name. So the coding is unique to each class in the sense that I return the instance variable that applies to that particular class. So I've got that part set up perfectly. I'm good with that. And again, this is a typical accessor method. I'm just saying that I want to be able, when I figure out who the highest bidder or the highest player or the highest participating classroom is, I want to be able to get back from those particular classes their unique instance variable identifying their player or their teacher or the highest bidder. So that's one reason why we say the coding or the implementation is left to the individual class. Okay, so I really can't go into measurable and put return item name. I can't put code here because then it wouldn't work for player because player doesn't have an item name. Now I have to make sure that each of these classes has a get amount method. So now when I come into player, I had put in get total tickets as my accessor to return the value in the instance variable total tickets. But the interface wants to use a more generic get amount name. So really, I don't need this. What I really need to do is just go ahead and say get amount, but in the player class it's going to return the total tickets. If I leave the other one, I just have redundant code. It's still going to work. It's still going to compile. But really what I'm saying is my accessor for the tickets amount in player, I'm going to call it get amount. I'm going to do the same thing in classroom. I need to have a get amount. Okay, I had originally called it get participants because that seemed, when I was doing the class before I thought about the interface, that seemed logical. But really, because the interface is saying let's use a more generic name, get amount, now I'm just going to have that get amount method here. And same thing in bids. Here, instead of having a get bid, instead of calling it get bid, which you might do if you were not doing an interface, you might name it something like that because that's unique to bidding. I'm just here again going to take the more generic get amount, and that's going to be my accessor, and it's also going to be part of my interface. Now if you leave these redundant methods like get bid, that's fine. You can leave it, it'll compile, it'll run, but it's really, I don't need that. I'm just showing you that if you were doing it without the interface, you would probably have an accessor called getBid in the bids class, and you would return the bid amount. Well, since we know that we want the highest bid amount, we're going to call it get amount in keeping with the more generic term in the interface, and we're going to return the bid amount. And so in classroom, we're going to use the more generic name, but look, we're returning total participants because that's what's important to us. In the classroom, we're going to get the highest number of participants. We're going to figure out which class had the most students show up, and we're going to figure out which class it is, which teacher, and then we're going to get back the participants. With player, we're going to figure out which student is the one with the most tickets, and then we're going to return that student's ticket amount, and that'll be the highest number of tickets. So now that I'm understanding that these two methods, I want to return not only the highest amount of tickets or bid, the highest bidding amount, etc. I also want to return the associated name, right? So I want to know it was student Jack or Jane or whoever that had the most tickets, and they had X number of tickets. So this interface basically helps me sort of standardize that each class that I'm interested in getting the highest amount back from, I'm going to have a generic get amount, a generic get name in the sense that the names are generic, but I put the specific return type for those instance variables, get tickets here, get participants here, and get amount here, okay, get bid amount. So I've put the implementation or the code down in the class, but I'm using the generic names that I set up here in the measurable interface. And that's it for the interface and how to hook them to the classes. Now the trick with this one is if you want to find out the highest amount, you really have to have a way to group everything together so you can keep a running comparison of who used to have the highest amount. I just added somebody. Is their amount higher? If it is, make them the person with the highest amount. So every time I'm adding a person, I'm comparing to the last known highest amount. So I'm always keeping in this group class, I'm always keeping the name and the amount of who had the highest bid or who had the most student participants or who had the highest tickets. And every time I add one, I'm comparing the person I added to the person that I last knew had the highest. If the new person has the highest, I swap. I say, okay, now person Y has the highest, and here's the amount that's the highest. If they don't, I keep the old person as the highest. So there's no looping or anything like that. I'm always just tracking who is the highest, and every time I add somebody new, I'm saying let's compare to the last known highest person. So I'm using the idea that in this group class, I want to be able to have it handle not only players, but I want it to be able to handle bids, and I want it to be able to handle classrooms. So I don't want to have 3 different add methods. This is where my code reuse is coming in, and it's really something you have to think about, which is why I gave you the code, because this is really tricky. I don't want to have 3 different add methods where one add method takes a classroom X, where one would have bids X and one would have player X. I don't want to have 3 different add methods, one for each different class type that I'm interested in. I want one add method because no matter whether it's players or classrooms or bids, the method for finding the highest is exactly the same. So I want one add method. If I have all of these classes implement this measurable interface, I can create a measurable data type. Measurable is like a custom data type that I have created now through that interface. And I can pass a player or a classroom or a bidder through this add method. Okay? And doing that saves me from having 3 different methods. Instead of that, I just have one. So that's why we say that an interface can help us with code reuse. Now, this is a really tricky example. Again, I'm thinking that it would have been a stretch for you to figure out that not only did you need 3 classes, you have to have this group and the interface and your main. That's why I gave you the code. But you can see here, by using the measurable interface, I can basically say, since player implements measurable, I can pass a player object to this add method and have it keep track of who's got the highest number of tickets. Then if I'm later on looking at bids, I can pass to the same method a bid object and have it figure out who's got the highest bid, and I can pass a classroom object and have it figure out which teacher has the highest number of student participants. So that's where we're saying the code reuse is coming in. This group class has one add method. Because each of these classes, player, classroom, and bids, has that get amount, and because they each have get name, look at what I can do. I can say, more or less sort of convert them to like a measurable type object because they implement the measurable interface, that's fine. And then use the 2 generic methods, get amount and get name, to figure out who has the highest amount, who is that person, what's the amount. Now here, I really probably don't need this. I reused some code from another project. In that project, I was keeping a running total. Like how many total bid, what was the total amount of all the bids, which would be totally irrelevant and makes no sense because only the highest bid wins. What was the total number of tickets that everybody got, which again, I really don't care about that. And this would also let me keep track of how many total students came. Okay. But again, I'm not really using that, so I probably don't even need that line in there. But if you wanted to keep a running total, if you were also interested in not only the highest, but okay, how many bank accounts today? What was the total balance of all the bank accounts? And then who had the highest total and what was it? You could use that. But for this example, I probably don't need it. Okay, I'm going to leave it in there. But the real crux of it is, if this is the very first bidder or first player or first classroom I've added, I will default them to being the highest value because there's nobody else, so they must be the highest. So the first person who puts in a bid on the silent auction item is technically the highest bidder. The first student who shows up, that teacher technically has the highest participation because nobody else's students have showed up. The first player to earn a ticket technically has the highest number of tickets to begin because nobody else has tickets. And they will serve as my point of comparison for everything going forward to figure out who's got the highest. So if it's the very first time that I've added somebody, that's why I have this nice little count variable here. That's all that's doing. Then set them up as the highest. Now when the count goes to anything greater than 0 for every subsequent thing that's added, what I'm doing is I'm saying take the person, the bidder, the student, whatever that I've just passed in, get their amount, compare it to what I have said is the highest bid amount so far, or the highest ticket amount so far, or the highest classroom participation so far. And if what I've kept as the max is less than the new person, swap them. That's all that's doing. Get the name of the new person, get the amount that the new person has in tickets or what the bid is or whatever, and make that person the new highest. And bump the counter up. Again, that's only to make sure that I don't have an issue when I have the first person added in, because there's nobody to compare to when the first person comes in. And if I didn't have this right here, this if statement would blow up. It wouldn't work because it would say, hey, there's nobody to compare to. So really the counter, once you get past the first person, is kind of irrelevant, but you have to have it. Now here, again, I set up this sum, but I probably don't need for this example. I was using some code from an old example. I do need the counter, and I've got to keep an instance variable for the name of the highest bidder, the highest player with the highest tickets, the highest teacher classroom with the teacher with the highest classroom participation. And this measurable maximum is going to allow me to track the amount, the highest number of tickets or the highest bid or the classroom with the highest participation, how many students came. And then in here, what I'm doing is I'm basically saying I'm passing in each of these objects as a measurable data type. It becomes a measurable object. And I'm going to store in my measurable object for each of these different types of classes the highest amount and the name of the person. So now when we look at player, or rather when we look at our main, you can see here's where I've got to set up the group. And this is going to be a group of players. I'm going to add various players to it. And notice here, what else do I have to do? I have to create a measurable object, and I'm calling it max. And then when I want to figure out or print out, after I've done all my adds, now this is important, don't print out the highest bidder or the highest player with the highest tickets until you've added all the players and all the comparisons have been done. So when I'm through adding players, I can come down here, I can use the measurable interface to tell me who had the highest number of tickets and what that number was. Notice here I create a new group for the classrooms, for the teachers. I can reuse my measurable object here, but notice instead of playerdata.getMaximum, I'm saying leaders.getMaximum. So I can reuse the measurable object, but when I'm figuring out who's got the maximum, I'm using the group name leaders here instead of player data. And same thing here with bidders. I add the bidders. Notice I'm not creating a new measurable. I guess you could if you wanted to. But I'm reusing the one that's there. But notice I'm saying now go look at the group of bidders and get the maximum person there. So I hope this is helpful. And I think it's kind of complex to set this up. But once you set it up, you can see that by having this measurable object, I do save myself a little bit of code here in this group class, because if I didn't have the interface, I would have to have 3 different add methods, one for player, one for bidder, one for classroom, and they'd all have the same code. They would just have different names. It might be add player or add classroom or whatever. And when does the comparison take place to figure out person A versus person B who has the highest? It's right here. Notice that when I set up this group, I'm saying go to the player data, go to the group class, use the add method. And it invokes the add method, and this is how it figures out, it keeps a running tally of who's got the highest whatever. So it all happens here. I'm using the constructor in the player class here, but I'm using it as a parameter to the group player data add method. So when you're adding a player, yes, you're creating that player, but you're creating them through the add method of the group. See, again, that's kind of tricky. So I'm passing player constructor information here, which, because this is an interface and because player implements measurable, it goes through and it still sets all this stuff up. It invokes all of this stuff here in the constructor, and then it comes back into group, and then it compares this person to the prior person and so on. So it's really kind of tricky, and it was a real complex process to set this up. I had to think about it. I had to plan. I didn't just sit down and start coding on this one, and that's why I gave you the code. This player or this group class always tricks people and always catches them, causes issues. So I gave you pretty much most of the code for that in group. And here, all you really need to do, I think in the assignment, I asked you to finish out all of the code here. And then I asked you to make sure in here, in each of these, that you put implements measurable in all three, classroom, bids, and player. And that you made sure that classroom, bids, and player all had get amount and get name methods. So that's really all you have to do. And then of course you have to finish out your main to get this thing working.